Hello, my name is Zachary Zio. Today I will be talking about 2016 FRQ number 4. It says, consider the following differential equation, dy over dx equals y squared divided by x minus 1. Part A asks us to sketch a slope field for the given differential equation at the 6 indicated points as shown by these points over here. I'm going to create a table of values to stay organized, but you don't have to. In order to find the slope, all you have to do is plug the points into the differential equation. So at the point 0, 0, the slope is equal to 0 squared divided by 0 minus 1, which is equal to 0. At the point 0, 1, the slope is equal to 1 squared divided by 0 minus 1, which is equal to negative 1. At the point 0, 2, the slope is equal to 2 squared divided by 0 minus 1, which is equal to negative 4. At the point 2, 0, the slope is equal to 0 squared divided by 2 minus 1, which is equal to 0. And we just continue that to find the rest of the slopes at these points. So after that, all we have to do is draw small dash marks with those slopes at the given points to get the points for this question. So at the point 0, 0, slope is equal to 0, so we can just draw a horizontal line to represent that slope. At the point 0, 1, the slope is equal to negative 1, so we just draw a downward sloping line with a slope of 1 to represent that slope. At the point 0, 2, we just draw a steeper downward sloping line to represent a slope of negative 4. At the point 2, 0, we draw a horizontal line to represent a slope of 0. At the point 2, 1, we draw a slope of 1. At the point 2, 2, we draw a steeper line to represent a slope of 4. So for this question, you actually didn't get any points for creating a table of values and correctly calculating the slopes. Instead, if you drew the slopes on correctly, then you received full credit. So if you drew the slopes of 0 at the points 0, 0, and 2, 0 on correctly, then you received the point. If you drew the rest of the 4 slopes on correctly, then you receive the other point. So that's the breakdown for the points for this FRQ Part A. For additional slope field problem practice, check out 2006 Calc AB FRQ number 5A, 2008 Calc AB FRQ number 5A, 2005 Calc AB FRQ number 6A, and 2004 Calc AB FRQ number 6A, all of which can be found on the College Board website and are great practice for slope field problems.
3, 2, 1, go.
Part B states that let y equals f of x be a particular solution to the given differential equation with the initial condition f of 2 equals 3. Write an equation for the line tangent to the graph y equals f of x at x equals 2. Use your equation to approximate f of 2.1. In order to get the slope of the tangent line, all we have to do is plug the point 2, 3 into the differential equation. So we know that the tangent line slope at 2, 3 equals 3 squared divided by 2 minus 1, which equals 9. So that's the slope of our tangent line. And then so we know our tangent line is in the form of y equals 9x plus b. In order to find the value of b, all we have to do is use our initial condition. So y equals 3, 9 times 2 plus b is the solution. So b equals negative 15. So in the end, the tangent line is just y equals 9x minus 15. That's f of x. And the second part of the question asks us to use our tangent line to approximate f of 2.1. So all we have to do for that is plug 2.1 into our tangent line equation. So we know f of 2.1 is roughly 9 times 2.1 minus 15, which equals 18.9 minus 15, which equals 3.9. So I put my line in the form y equals mx plus b, but you don't have to, you can leave it in point slope form. So for the first point, all you had to do is find the tangent line correctly. For the second point, you're supposed to use your tangent line to approximate f of 2.1, so those are where the 2 points for this part of the question come from. For additional practice, you can check out Chapter 9 notes number 9 CD, which can be found on Mr. Shea's website, and the 2015 Calc AB FRQ number 6B, which can be found on the College Board website, and the 2000 AP Calc FRQ number 5B, all of which are great practice for this topic. For part C, we are supposed to find the particular solution to y equals f of x to the given differential equation with the initial condition f of 2 equals 3. So our very first step is we want to separate the variables. So we know dy over dx equals y squared divided by x minus 1. We can separate that and get 1 over x minus 1 dx equals 1 over y squared dy. And from there, we can integrate both sides, and we get negative y of negative 2 to the power of negative 1 equals ln of x minus 1, absolute value around that, plus c. And then from there, we can isolate y. So we know y equals negative ln of x minus 1 plus c, y to the negative 1. So we know y equals 1 divided by negative ln of x minus 1 plus c. And from there, we can just plug in the initial condition to find the value of c. So we know 3 equals 1 divided by negative ln of 2 minus 1 plus c. So we know negative ln of 1 is just equal to 0. So therefore 3c is equal to 1. So c is equal to 1/3. So we can just plug the value of c back into our equation. So we know that the particular solution is equal to negative ln of x minus 1 plus 1/3. So the very first point you get is for correctly separating the variables. If you don't correctly separate the variables, then you lose all your points for this part of the question. And the next 2 points you get are for correctly integrating both sides of the equation. So if you got negative y to the power of negative 1 and ln of the absolute value of x minus 1, then you got 2 more points, and this is the very first point. If you didn't add the constant of integration, you got 3 points if you correctly integrated both sides of the equation, but you weren't eligible for the next 2 points. And if you applied the initial condition, then you got another point. In finding the very end answer, you get the very last point, so that gives you a total of 5 points for this section of the FRQ. You don't have to isolate y directly as I did. As you can see, you could have directly applied the initial condition at this step, but I chose not to. For additional practice, you can check out 2016 Calc AB FRQ number 5B, 2008 Calc AB FRQ number 5B, 2005 Calc AB FRQ number 6C, and 2004 Calc AB FRQ number 6C, all of which give you good practice for separating differential equations and finding particular solutions. And these all can be found on the College Board website.